Hi everyone, in this video I'm going to talk about one of my biomechanics class student sent one video in the group to ask something. Just watch this video, I'll clarify the doubts.
So I have doubt in one exercise. For example, I want to train the internal rotators of my right shoulder. I would be demonstrating 3 exercises. I want to know how my internal rotators are being loaded in these 3 exercises.
Okay.
So the first exercise is simply from neutral position of the shoulder. I am going into internal rotation and coming back to center. Again into internal rotation, coming back to center. In gravity eliminated plane.
Here, see, to target the internal rotator, there is no enough resistive force. There is no enough resistive force to target the internal rotator. Gravity pulls down, may you isometrically stabilize the arm like this. That's all happen. So nothing works here because there is no enough resistive force.
In second exercise, I'm just grabbing a dumbbell. In the same plane, in the same range, I'm training again this internal rotation. Again going into relatively external rotation. And from neutral, again coming into internal rotation. This is the second exercise.
And here the problem is, as soon as you hold the dumbbell like this, then resistive force of weight comes into play along with the gravity. It put you down. The resistive force for elbow extending, resistive force direction of elbow extending, not for the internal rotation. So our biceps muscle work isometrically because it's putting down against resistance. You're holding the dumbbell, so muscle force and resistive force are neutral here. So the resistive force casting moment is elbow extension, elbow flexion you're maintaining. So elbow flexors work isometrically instead of the internal rotator.
Now in third exercise, I'm actually using a band.
Okay.
And again the same movement from neutral position. I'm taking my hand into internal rotation.
Great.
And then going back, again taking it into internal
Here
rotation.
internal rotator work efficiently because the resistive force is, the band is coming and resistive force exactly to the internal rotation. Resistive force to the internal rotation, movement also happening in internal rotation. Okay, so band is pulling in this direction, band is creating the external rotation force and you are creating internal rotation force. So the resistive force and muscle force in opposite direction. So the which movement is happening, that same muscle work concentrically. The same muscle work concentrically. When you leave resistive force for external rotation, your movement happening external rotation. So when you leave, the external rotation is going to happen. So movement is happening to external rotation. So external rotator doesn't work here because resistive force and movement direction in the same place. So opposite muscle group as the internal rotator work eccentrically when you lengthen, if you control the movement. The main thing here is I would like to take another lengthy band because of the resistance is very short and you are standing too closer to that. If you stand little outer, so allow full range of motion in a external rotation, from you can bring back to internal rotation. This shortest range of motion also works if you in a initial rehab phase the patient have pain. Hope it makes sense to you. This is how our EP classroom works. Happy learning.